We've got 0.17 moles per liter, SO2, 0.11 mole per liter, NO2. How much product do we have, Nikita? 0. So now you have to put in your change. Does anybody not understand the change part? Okay, Saeed, do you have a question?
Do we have to put X in this question?
Yes?
Do we need to change them?
No?
Oh.
Not yet?
Oh, so it's easy.
Okay, we're doing an ice table. Okay, so then we've got 0.17 minus x, 0.11 minus x, x, and x. So you have to still set up your ice table. What they also tell you is the concentration of this, which happens to be x, so now you can substitute it back in and get your values.
Oh my.
So that's how it would be, right?
That's how it would be.
So that's,
So this would be the equilibrium concentration of SO2. You notice how I'm putting concentration brackets in equilibrium would be 0.17 minus 0.089
Wow.
moles per liter, whatever value you get there. NO2 at equilibrium, 0.11 minus 0.089 moles per liter. And then NO at equilibrium is equal to SO3 at equilibrium, which equals 0.089 moles per liter. So if this is our equilibrium reaction, and this is our K, does this reaction go very far? Where does equilibrium lie? To the left or to the right? Why? Yes, that's very much smaller than 1. So you have very little nitrogen trichloride decomposing. So most of everything that you have in this container is molecules of NCl3, nitrogen trichloride. Very little nitrogen and chlorine, which would probably be very good if you were trying to make nitrogen trichloride. Okay? What would the K value be for the opposite direction? How would you find that? For the synthesis, the formation of nitrogen trichloride, how would you find the K value? Say that louder.
1.
Yeah, it's 1 over the K value. So if it's 1 over a K value, will that number be very small or very big? Very big. Yeah. All right. Can I hear the rest of the values, please?
So it's 1 liter, and then it's 4.6 times 10 to the negative 6 moles of nitrogen gas at equilibrium.
Okay, so at equilibrium, we've got 4.6 times 10
To the negative 6?
to the negative 6 moles per liter,
Yeah.
okay,
And,
of N2,
yeah, then 2.
okay? And that's all you've got?
And you need to find the amount of nitrogen trichloride gas.
At equilibrium?
Well, it says what amount of nitrogen trichloride is put into the reaction vessel.
Oh, so we want initial. Interesting. So, zero, because you never have any product before you start the reaction. So the change, what will be my change for NCl3? Tamara? Negative 2x. And my N2 will be x and 3x. All right, so I almost did. Here we go. We good? Now, it will suck if we set up our equilibrium expression and have two unknowns in it. It's hard to solve for two different unknowns in an equation. So they must have given us a little piece of information to get rid of either the n or the x.
The x is the 4.6.
Yeah, the x is the 4.6. So now,
Wow.
we know that, we know that, we know that. Now we only have one unknown, and that unknown is n. So, N2, 1.38 times 10 to the negative 5. What's 3 times 4.6 times 10 to the negative 6?
Yes.
That's correct. Okay. All over n minus 9.2 times 10 to the negative 6. On there, and what goes on this one? 2. Somebody's awake. Yay. Okay. Are we okay with this? Yes or no? Yep.
Oh, where did you get the 9.2 and the 1.28?
X is 4.6.
Oh, really?
2 times x. X is 4.6. All right, now, what do you want to do? It looks like it's going to be pretty nasty, doesn't it? We could foil the bottom, expand and everything, but chemists, because they know they can. It's not because they just want to take shortcuts, it's because they're efficient. That's a pretty small number. That's a pretty small number. So there's a pretty good chance that this divided by this will be greater than 1,000. So let's roll with that assumption first. So we're going to assume n minus 2x is approximately n. We can't prove it yet because we don't know what n is. So we're going to make that assumption. So 4.6 times 10 to the negative 6 times 1.38 times 10 to the negative 5 cubed all over n squared 3.3 times 10 to the negative 12. Let's see what answer we get.
Can't even round it. Still go. Wow. Well, just round it to 1 then. Just do 1 times 10.
So, that would be moles per liter. Now, go back and check our assumption. So, if our assumption was correct, we would take 6.05 times 10 to the negative 5 We would divide it by our K. Is that going to be bigger than 1,000?
I don't believe, actually, no.
What?
You don't.
There's a difference of
No, I
exponents
didn't.
here of 7.
No, I didn't mean to say that.
So we're looking at 6 figures.
I was trying too hard on the accent, I didn't mean to say that.
What number did you get?
Say it's greater than 1,000.
It's taking a long
Holy.
It's big, right?
Now, are you sure it's not greater than 1,000?
It's not. 18 million is smaller than 1,000.
Okay, so come work for me. I'll pay you in pennies and you'll be happy as a... Okay, so our assumption works, so that's how you get your answer. The initial concentration was 6 point, how many significant digits can we have? 2, so 6.1 times 10 to the negative 5 moles per liter. Okay? If it was wrong? What? What if the assumption's wrong? A C, O, C, double bonded O, functional group. That identifies that as an ester. So then, these are your 2 groups. So what's the name? What's my name? What's my name? How many carbons? 1. Because carbon is a C, right? Meth, what?
Is it methanol? Is it,
Say it, Christina. Methanoate. Methanoate. So, your alcohols are always named for the side group with the same number of carbons. And your acid portion that has the double bonded O, you keep this part from the acid, methanoic acid, and you stick 8 on methanoate. No? So what would you name? What would you name that? I'll pause.
okay, so you're looking for the number of carbons attached to the single bonded O?
Yeah, and that's the first part. And you just name it like it was a side group for hydrocarbons, like we did at the very first. Remember we did methyl groups, ethyl groups, propyl groups,
Yeah.
when they were on the side chain. You do the same thing, and then you count the carbons that is attached to the portion with the double bonded O. A common mistake here is to not count the carbonyl group carbon. A lot of people ignore that carbon and just count these. There's 3 carbons, so it's propanoate, not ethanoate. So well done. So what would you call this? What's that called? Because that's an H attached to that O. This group here is the functional group for carboxylic acid. This OH is no longer like an alcohol. It's acidic, it's not strongly acidic. But basically what happens is that O comes off and makes a hydrogen ion, which you're all familiar with. Acids. So it's weakly acidic. So all of your organic acids are weak acids, so they will form equilibrium, which is why we do acids and bases with the equilibrium unit, because we're going to start working on these in the next unit. And they're going to be in equilibrium reactions. Any other questions, ladies? Sometimes we test a reaction to see if it's at equilibrium. So sometimes we test a reaction to see if it's at equilibrium. We measure the concentrations and set up a trial K. So we set up a K expression, except we call it a Q. So we set up the same expression, we call it a Q instead of a K, and then we compare this value to K. So we compare the value to K, and we will know if it's at equilibrium and if not, which direction the system will shift to achieve it. Okay, so Q is equal to the concentration of products over the concentration of reactants. If Q is equal to K, system is at equilibrium. If Q is less than K, if Q is less than K, what does that mean we have more of? Products or reactants? So if Q is less than K,
More product.
we have more products or we need more products? No. If Q is larger than K, then that means the products to reactants must be larger on top. If Q is less than K, then we've got too many reactants, because the number would be smaller. the system will shift to the right to make more products. And then your Q gets bigger. If Q is greater than K, the system will shift left to make more reactants, so that the concentration of reactants increases, which will decrease the Q.
Excuse the interruption to class for the students going on the math neg.
H2 to the third order, N2 to the first order. Plug in your values. Figure out what your Q is. Your Q to your K. Is it equal? Is it bigger or less than? Less than, much less than. So therefore, in order to increase this ratio, you're going to need a lot more of this than this. You want your Q to increase, a bigger number. So if you have a big number divided by a smaller number, you get a big number. So therefore, this one is going to proceed to the right. It has to make more products.